Okay, are you able to hear me now? Please send me a message. Okay, okay. Then we can start. As I was saying, I come back to share my PowerPoint. As I was saying, as an initial consideration, now you may have heard that the materials are in the website, in my web page, and whilst the lectures are going to be on YouTube. Okay, let's carry on. Let's carry on with what we were saying last time. So we have basically two problems. One is the substitution of petroplastics or plastics obtained from oil with bioplastics or bio-based plastics, which is not the same thing, because basically bio-based plastics would like to substitute exactly with the same materials, like, for example, polyethylene produced from ethanol. So we use biological means, we use biological species or plant oils, for example, to obtain the same plastics we are currently using as obtained from oil, as petroplastics. Then we have bioplastics, and bioplastics are obtained from biological principles and biological items, or like starch, so derivatives from the polysaccharides. And these are different plastics from the petroplastics. Then we have also another category of plastics which are obtained from petrol, and which are obtained from petrol, and they are biodegradable anyway. So one characteristic we can say, we can decide, we can make a discrimination of, it's the biodegradability. You may have heard from the previous lectures that biodegradability is not the same thing as compostability. Basically, the process is the same: interaction with nature, with microorganisms, algae, human environment. The human environment. I think you hear me back again, isn't it? Because yeah, I see my image now. So okay, I was saying economic, environmental, and social. Sorry, but we are struggling with WebEx today. Okay, so these three kinds of sustainability. Then we can try to make we can try to make differences between economic, environmental, and social. So sub differences in a sense. Economic means capital costs, operation and maintenance costs, and fuel costs. Operation and maintenance, O in and M, means the cost you undergo during service, which basically are calculated on a year basis. Then you have capital cost, which is at the beginning. If you want to start doing something, you undergo a capital cost. And of course, you have fuel cost. And fuel cost may vary because you may have different kinds of fuel, which makes a lot of a difference also in terms of environmental sustainability, because the way you produce energy makes a lot of difference. Are included into environmental sustainability. You will have the recording, because I'm sure it's a recording, because I can see my video and hear my audio, so in the microphone. So the recording should work. If it is not the case, we will see what to do later on. Environmental factors involves a number of sub-factors which are exposed here, and these are around 12 factors, which have each one of these have got his importance, and they depend a lot on what you want to do. You can see that in, for example, in the case of plastics, some are more relevant, others are less relevant. For example, global warming, so the production of carbon dioxide, it's usually quite relevant for most cases. Acidification means acid rains, means the presence of sulfur dioxide, then of sulfuric acid into the atmosphere, which give rise to acid rains, but other factors are less of interest in our precise case. Okay, well, we can discuss that later on, but when you come to social factors are connected with quality of life, therefore with health, therefore with injuries and casualties and so on. Going further, you may imagine that, let's try to be more precise about this. Capital costs involve a number of items. The land on which you build the factory, for example. You have a factory that produces petroplastics, and you have a factory that produces bioplastics, and these factors Okay. Okay, so resuming the explanation, as I was saying, you may resume the explanation. Sorry, but it's easy for me to. Okay, so we were talking about the different um, types of the different aspects of sustainability. Then I suppose we can concentrate on what is our objective, so environmental sustainability. Environmental sustainability, which involves, as you were saying, a number of aspects. I was mentioning acid rains, and I was mentioning also the global warming, for example. But you could have a number of aspects like ozonization, like eutrophication, etc. And let's see if we can carry on to the end. So we have social sustainability, which has a number of aspects. Only some of these apply to material substitution. Apart from the specific aspects of what is implied in environmental and social sustainability, it's more important for us from a methodological point of view is that we want to understand what applies to our system and what doesn't. Something can also partially apply less than other factors. So it is important that we define the boundaries of the system. So, in practical terms, you want to compare the production of and the service and the end of life of petroplastics with the same aspects in bioplastics. There is something that you need to consider. For example, global warming might be different. Other things you may not consider, or you may decide to neglect. Some of these aspects, these are very general aspects, and you may consider, for example, health, quality of life, and well-being as going to be considered. Safety, of course, is to be considered because different ways of working may generate a different ways my problem, even if the substitution leads to better life conditions. But if people lose their employment, that might be an aspect to consider into the whole of sustainability. There are other aspects which are interesting, and it is something which is probably not obvious, but needs some attention. For example, let's consider last time we discussed about the substitution of fiberglass, of glass fibers, with Kurawa fibers for automotive industry applications. This involves one fact, that you start from a generally available material, a worldwide available material, because if you have sand, even if you don't have that much sand, or in other words, silicon dioxide, you can produce glass. You can import sand and produce glass. To import a fiber which is not your fiber, which doesn't go in your place, might represent a problem. Then there is the problem with sustainability. Then there are other problems with seasonality, etc. So what happens in practice? That you need to consider the use of your natural fiber. Every place in the world has got his or a number of natural fibers. For example, in Italy, we use it to have hemp, and hemp have worked very well. And these ideas are not very new in the sense that Henry Ford, which had the homonymous car company, was considering substituting fiberglass with hemp glass, wet fiber composites in the 30s, in the 40s. But this could work. This could work, but his idea was to plant lots of hemp fields in order to have a provision of a supply of hemp for his company. That was a good idea. That was a good idea. On the other side, if this doesn't happen, if you want to use sisal, for example, and sisal is mostly in Brazil, and you are in Italy, you are, for example, Fiat in Italy, and you want to use sisal, then it's not obvious. On the other side, any natural fiber, whilst the synthetic materials are not a part of a culture, natural fibers, like hemp, are part of a culture, in the sense that you may have hemp fiber composites, so fibers to be used, for example, in the automotive industry, but hemp is used in textiles, or have been used in textiles. It's used to make oil. It's used for other reasons, and therefore there is a culture, there is a productive system, which is socially more sustainable. If you have a productive system, and if you are a small part of this productive system, then you have also economic value, because, for example, you may consider planting hemp to produce oil. Then you are left with lots of fibers, with lots of waste. The wood you can plant the whole of waste in different industries and so on. You come back to your cultural tradition, because that you might have a traditional works which you can introduce back again, and you can preserve the traditional employment, but also you can give more value, more industrial, more newer value, in a sense, from new industries. Okay, this is strictly connected with environmental sustainability. Instead, you have these factors, you have these risk factors. Two things are to be considered into that. It's not a question to learning by heart the risk factors that you have. Two things are important. You need a unit to measure the risk factor. You see that on the right side, you have units. So global warming is produced by a number of gases, greenhouse gases. The most diffuse, the most widespread is carbon dioxide. So we relate everything to carbon dioxide. Of course, there is also carbon monoxide. There might be also nitrogen oxides, but you connect, you relate, giving some weighing factor. For example, you may say that, well, it's an example, it's not true, of course, it's just an example. You may say that 1 kilo of or 1 cubic meter of carbon dioxide is gives the same impact as 4 cubic meters of, say, nitrogen dioxide. Okay, and so we need units. We need units. We need weighing factors because we want to give numbers. Of course, in every process, as I was saying before, not all factors have the same value. You may have cases in which, for example, in our case, I would suppose, as I was saying, that global warming is important. That abiotic resources depletion might be important for when extracting oil. Then you may have eutrophication instead for bioplastics. Why? Because eutrophication is obtained by an amount of fertilizer, the amounts of fertilizers and pesticides that you use. If you use more fertilizers and pesticides, pesticides may have an effect also on toxicity for humans and even for ozone depletion potential, because something are based on chlorine. CFC means chlorofluorine carbides. But you can look at all the details. You find this everywhere, really. So less abiotic resources depletion or no abiotic resources depletion for production of bioplastic, more eutrophication though. So this is not a question, this is good, this is bad. It's always a question of a balance. Not trivial, as I was showing. Okay, going further, I would keep it short today because of all these problems. I hope to get a decent recording. This is the whole, I would say, the main reflection. So you may consider that some reasons are advantages for being bio, some others are against bio. So it's not as some people put it, that everything which is bio, it's better. There are a number of reasons to introduce bioplastics or even bio-based plastics, and others are against. So, for example, there is the main question. Well, here there is a lot to read, and you may read, but I don't like reading slides because you are not there, because for the reason that you can read the slides by yourselves. But the idea here is that the main idea is food competition. If we use something which is bio, that means that we compete with something that could be used to produce food. Not all biological species are adapted to produce food. There are some which are quite poor at food quality. An example is rapeseed, castor oil. In Italian, we refer to them as colza, ricino. They are quite poor in terms of food quality. So there isn't much competition. But think of corn. Corn, there is a lot of competition. You could plant corn to produce bioplastics, and then you have a lot of competition. Then you have a question about land. In which land are we going to plant these crops? Was it a wasteland, an unused land, a land which was abandoned, possibly? You may see around Camerino we have lots of abandoned plants, and someone may think I would plant something to recover the land and make some use. I could plant them for food, but since we are few people here, possibly there is not much need for food, I could think of bioplastics. It depends. I'm not thinking, I don't want to plant corn in Camerino to make, also because the soil possibly is not very adapted to make bioplastic. That's not my idea. But my point is that you could think that bio is good depending on local characteristics. So it depends where you produce it. Then there is another question. The question is about the rapidity, the speed of biodegradation, the point of biodegradation, because it's an important. The media tend to present biodegradation as the solution. Biodegradation might be a solution, but consider that biodegradation wipes out of the picture, in most cases, recycling. If something is so degraded, then it's difficult to recycle it. I explain it better. If something is biodegradable and this is fast and it is compostable and I can put it in compost and I can use it for agriculture, then it's a good point. If it is biodegradable but it's slow, biodegradation is slow, what I'm doing, I'm just affecting the possibility to recycle it, because if something is biodegraded, that means that I could recycle it, but probably the properties would be very poor. For example, think polylactic acid. I could recycle polylactic acid, PLA, but since it's so biodegradable, I would have a material with poor mechanical properties, and I could recover maybe 10% of the initial material with lower mechanical characteristics. Is it worth the price? Don't know. It depends what are the competitors again. Anyway, and how much polylactic acid I am able to produce, which is the doesn't like very much monoculture. Whilst in the case of bioplastics, if you want to have a large amount of corn starch or of potato starch and whatever, you need a big monoculture. For potatoes, this is not a big problem because potatoes are tubers and don't tend to spoil the soil. In some countries around the world, in the United Kingdom, for example, they say if you don't want to be deceived, if you have an allotment, if you have a field, you don't want to be deceived, plant potatoes and you will get always potatoes. Corn is much more tricky. It's nastier in a sense because it tends to eradicate all the rest of the plants. It doesn't like to have have kind of friendships with other plants. I'm saying this in a very simple ways. These are not precise biological terms, but to make you understand, for example, soy, it's a good friend of corn. And if you want corn to survive, please plant soy. This is a bit forcing the thing because then you plant soy together with corn. Can you produce soy bioplastics? Yes, you can produce soy oil bioplastic. Yes, but in the end, in a few years, you will have the effect would stop of both this kind of friendship of symbiosis between corn and soy. And in the end, what you end up is when you depopulated the land. I was talking about potatoes, though. Potato is a good point because I'm not. I don't want you come out from the lecture saying that potatoes is good and corn is bad. But there is a question about potatoes. You can use waste. You can use potato skins to make starch. That's a good point. I'm not sure we can survive all with potato plastics, but the main point is that we could use waste. Why not? We could use waste, and that changes the impact, reduces the impact, because we want to get rid of waste, and we use waste to produce a plastic, which delays our problem because the plastics could last for some time and be compostable and so on. So we don't have waste that we need to use at the land as landfilling, but we can produce plastics which might be also recycled. I assume that you are hearing me. I hope so. Okay, let's carry on then. Oh, there is another question, which is OGM, which is the genetic modification of plants. There was a period in around 2000 where people were concerned about bioplastic and wanted to be sure that bioplastic were OGM free, which is a market. There is a market for that. Of course, it's difficult to get bioplastics OGM free because they need some yielding, so high yielding that is, of course, genetically modified in some way to improve yielding. Also to make them compatible with fertilizers and so on. Remember that fertilizers increase eutrophication because your plant grows, but also algae, for example, if you are at sea, or other weed plants, if you are on land, grow as well. And so you may have, if you are at sea, or if you are discharging water and if you are in water streams and so on. Okay, so there was, for example, another stream which was important. It was about gluten-free bioplastic. It's more than just a joke. It is something that has its own market. What you need to retain from all that, what is important that you retain, is that we need to look at the whole of the project and the whole of the different aspects, and we need to establish boundaries of the system of your comparison between the bioplastics and petroplastics based plastics. Two aspects. When you want to concentrate on comparison, for example, you want to compare plastics. You know that plastic bags came out and at a certain point in history, in the 50s or 60s, before there were paper bags. There is still market for paper bags. Paper bags are produced from cellulose pulp. Cellulose pulp, it's really the last life of paper. It's paper was no longer used. You can compress it and make some egg containers, for example, egg packaging. The most common ones are in cellulose pulp. But you can also produce paper bags. Paper pulp. You know, pulp, apart from problems with chlorine, remember that cellulose pulp is heavily treated with chlorine. So it might be incinerated, but then you get in the atmosphere some chlorine full chemicals. Chlorine containing chemicals like even hypochlorite, sodium hypochlorite, which is used a lot for disinfection. We know all these days it's used disinfection. But in paper is much more concentrated than the one we use for disinfection. So it creates some environmental impact. Then we have impact for paper production. I could show also later on the paper production system, which involves a number of stages. This is a general aspect. And we had basically these four big items. So we produce pulp, we get cellulose, we produce pulp. From recycled pulp, from recycled paper, it would be better. If we produce it from end-of-life paper, it would be better because it reduces the environmental impact. We need to produce paper, we need to print, and then you need to shape them into a bags. So it looks very simple. Instead, you have the substitution was with LDPE, low density polyethylene, or with linear low density polyethylene. It depends on the kind of surface finishing you have on your bags. There are bags which are more glossy and other bags which are more rougher. You may, if you look at supermarkets, you may remember the old bags, especially the so-called old bags, but bags which are not biodegradable. There are some which are rougher and some which are glossier. It's always polyethylene. The polymer chains have a different aspect, are more or less linear. And it's a low density polyethylene, which is whose density is around 0.9. But the question is, you are not able to shape it on high thickness. When I say high thickness, 2-3 millimeters. Here you have bags. It's a question of less than a millimeter, half a millimeter, 500 microns, less, even less, 100 microns in many cases. So in production of plastic bags, you have a number of processes which is much larger. So the complexity of the system is higher. You have oil, you have a feedstock. With the part of the oil is cracked. When I mean cracked, I mean it's decomposed with temperature in different stages. In next seminars, we will have the pleasure to have a professor which will talk to you also about oil questions, about the way and all the way oil is differentiated from all the different components, like bitumen, like naphtha, and so on, like natural gas, of course. This is a quite complex field. There are entire university courses just dedicated to oil extraction, to oil cracking. And then there is the part of oil which is fed to the production of plastic, or the polymer. Remember, as I was saying last time, that polymer and plastics I try to complete it very quickly. So you have for example, to provide easy opening. Then you pack them, and then there is a packaging. There is some cardboard involved, for example. You may have some cardboard packaging. The big question is where to stop. Do I need to consider also cardboard packing, and therefore its impact? If I want to produce cardboard, I have some impact given to the production of cardboard itself, given to glue, given to over packaging of the packaging, because I possibly need to carry on packaging and to put some big packaging into lorries, into trucks, and therefore I need more plastics possibly to do this. So the first consideration we can do that is that the introduction of plastic bags has complicated the system. It is not important that you put immediately number down these things because it might be also difficult, but it is important that you understand the different phases of the project and of the production also of your project in terms of environmental sustainability and also of the production. Okay. Then we need to consider other cases. This is a case which is quite interesting, quite present in a sense. You know that we are using bottles Single-use bottles. Now there is a lot of discussion about single-use. Single-use should disappear, which is a point. Well, it should disappear because single-use forms a big part of the um, production of waste. Most production of through single use. We have objects like these bottles, these polyethylene terephthalate bottles, which are used just once, which means that if they are used just once, the other problem is that they become immediately waste and therefore in large quantities. Under the sun, they biodegrade in they degrade under the action of the sanitation, but they have assigned different weights. They have assigned different weights to the three categories of risks. And in practical terms, the three sides of the triangles represent human health, ecosystem quality, and resources. And you can have different solutions, A or B, for example, provided you assign more importance to one or to another. You may consider, for example, you don't have a big problem with resources, for example, you have lots of petrol, lots of oil, and you can consider that for you, resources is not more important than ecosystem quality. Or in other cases, you are in a deserted land and therefore you have no problems with land use. If you have no problems with land use, then the ecosystem quality can be lower. Okay, I think we are about at the end of what I wanted to say. The last example, for example, it's which is posed now, is that polylactic acid maybe is not the best, the most efficient plastics which can produce from cornstarch, because it's less performant than others. It's not, and therefore we could, for example, produce polyhydroxybutyrate. Polyhydroxybutyrate, PHB, is the competitor of PLA. For example, our raw material is always cornstarch, but we can try to produce polyhydroxybutyrate instead of polylactic acid. And if we want to compare, we need to have a number of I need to correct the slides because these were translated. Some of these were translated. So I will correct the slides. Anyway, there were some aspects. The last one is the recovery process. The recovery process means, can I burn that into an incinerator? And what is the impact of doing that? There are some matters, there are some elements which have some impact. And some, to the left, you find the different aspects. Okay, next time we will repeat about the same things. Well, I will expand a bit more. I will